Hi, welcome to Algebra 2 Common Core. Today we're going to talk about a third trigonometric function, the tangent function. We've been working in this whole unit with sine and cosine, but you should recall from geometry that there was a third trig function known as the tangent. So if we look at our right triangle shown in the diagram, you should remember that the tangent of the angle that is designated, so in this case this angle right here, the tangent is always equal to the opposite side divided by the adjacent side. So if I look at the diagrams in example number 1, I'd like to find the sine, cosine, and tangent for each of these angles inside the triangle. So you'll notice that this is the angle that we are looking for. Now, in order to find sine, cosine, and tangent, you might have a mnemonic where you remember what each is equal to. Maybe it's Oscar had a heap of apples, or you might use SOHCAHTOA. I'm going to spell out SOHCAHTOA for us. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So however you remember your ratios for sine, cosine, and tangent, we're still going to be using those ratios. In part A, I see that I'm missing one of the sides of the triangle. So if I don't recognize that triangle, I do have to go off to the side and do the Pythagorean theorem and say hypotenuse squared is equal to first leg squared plus second leg squared. And we see, of course, that this works out to be 25 equals 16 plus x squared. So x squared is equal to 9, and therefore x is equal to 3. So label that missing side. Now we're able to use all three sides to identify the sine of the angle, the cosine of the angle, and the tangent of the angle. Please notice that we're not ever talking about what the angle measurement is. We're just talking about these trig ratios. So let's go ahead and do the sine of theta. Sine is, of course, opposite over hypotenuse. So from that angle, we're going to go the opposite side is 3 over the hypotenuse is 5. The cosine of the angle, cosine is adjacent over hypotenuse, so adjacent just means next to the angle. So that's going to give me a 4/5. And for my last trig function, the tangent of the angle is going to be opposite over adjacent, so that should be 3/4. These should be pretty easy ratios for you to calculate. In part B, let's go ahead and find the missing side of our triangle again. Again, I know the hypotenuse, so 2 squared is equal to 1 leg squared plus the other leg squared. So I've got that 4 is equal to 1 plus x squared. So x squared is equal to 3, and therefore x is equal to the square root of 3. So sometimes we will get irrational sides on our triangles by using Pythagorean theorem. So to do the sine of the angle, I'm going to say opposite over hypotenuse. To do the cosine of the angle, that one's going to be adjacent over hypotenuse. And finish it off with the tangent of the angle. Tangent is equal to opposite over adjacent. So radical 3 divided by 1 is just radical 3. Now in geometry, your focus was more on using triangles and evaluating trig functions within the triangles. In Algebra 2, our focus is more using the unit circle. So now let's apply what we know to our unit circle diagram and see what we can find out about tangent. So in example number 2, it says consider the unit circle. If I want xy, and if xy represents a point on that circle, how are we going to define tangent? So I'm going to go to my angle right here and say, notice that I've got this right triangle, and I still know that the tangent is equal to opposite over adjacent. So in this case, the opposite side is equal to y, and the adjacent side is equal to x. So tangent in terms of our unit circle will be the y-coordinate divided by the x-coordinate. Now we've been using this unit circle throughout this chapter, and we've always said that within the unit circle the y-coordinate really represents the sine of the angle, and the x-coordinate really represents the cosine of the angle. So this definition is a very important definition for us for the tangent of any angle. The tangent is always going to equal the sine of the angle divided by the cosine of the angle. That's going to also provide us with a nice easy way to evaluate tangent, especially in the unit circle, because we've gotten very good at finding sine and cosine within my unit circle. So in the definition box, let's go ahead and once again write that definition. Tangent of theta is equal to sine of theta over cosine of theta. Now within this definition box, I'd like to take a minute to also look at the sign, S-I-G-N. That means, is tangent positive or negative in each quadrant? So let's just recall that in quadrant number 1, I know that my x-coordinate is positive and my y-coordinate is positive. So since tangent is sine divided by cosine, when I divide positive by positive, I'm still going to get a positive answer. So I'm going to put the tangent in red. In quadrant number 2, I know that my x-coordinate is negative, my y-coordinate is positive. So when I divide sine by cosine, I'm getting a negative answer for my tangent. In quadrant 3, I know that both the x and the y are negative, so when I divide negative by negative, that's telling me that the tangent is going to be positive in that quadrant. And in the 4th quadrant, my x-coordinate is positive, my y-coordinate is negative, so when I divide negative by positive, the tangent will be negative in that quadrant. So I can see that the signs, S-I-G-N-S, of tangent are going to be dependent on what the signs are for sine and cosine in each quadrant. Now let's go ahead and look at example number 3. We're going to use our unit circle and the definition of tangent in order to find the value for each of the following. We want to make sure that we simplify our answers as much as possible, meaning that we're not going to leave any complex fractions. I'm also never going to leave a radical in the denominator of my fraction. So for tangent of 60, I know that tangent of 60 will just be equal to sine of 60 divided by cosine of 60. So I'm going to go to the bottom here and I'm going to make the unit circle diagram for 60 degrees. And I think we've gotten very good at using our unit circle. So here I've got my 60-degree angle. Across from the 60, I know that side is going to be radical 3 over 2. Across from the 30, I know that side is 1/2, and the hypotenuse is 1. So I know that my answer for sine is going to be my y-coordinate. So I'm going to use radical 3 over 2. But I have to divide that by cosine of 60, which is 1/2. Well, when I have a fraction divided by a fraction, all I'm going to do is say, let's take radical 3 over 2 and multiply by the reciprocal, 2 over 1. You'll notice that the 2's cancel, and my answer for the tangent of 60 is going to be radical 3. So there we go with our value. Notice it is irrational. Now let's go ahead and do tangent of 45. That means I want to find the sine of 45 and divide it by the cosine of 45. Make your unit circle. In this case, I'm talking about my 45-degree angle. So let's make our 45, 45, 90 triangle. We know that each leg is radical 2 over 2, and the hypotenuse is 1. So the sine of 45 degrees, radical 2 over 2, divided by the cosine of 45 degrees, also radical 2 over 2. And anytime I divide a number by itself, that's just giving me an answer of 1. So the tangent of 45 degrees is equal to 1. Let's go to 150 degrees, so that means that I need to know the sine of 150 divided by the cosine of 150. So making my unit circle, this time 150 degrees is in quadrant number 2. So that puts a 30-degree angle right here. Across from the 30 is 1/2. Across from the 60 is, that one should be my hypotenuse of 1. So down here I should have radical 3/2. So the sine of 150 should be the y-coordinate, 1/2, divided by the cosine of 150, well, that's going to be my negative radical 3/2. Once again, I'm going to have to divide by the reciprocal, or divide by multiplying by the reciprocal. So I'm going to say times 2 over negative radical 3. Cancel off those 2's, and that gives me an answer of negative 1 over radical 3. Now I'm not going to leave my answer like that. I want to rationalize my denominator by multiplying the top and the bottom by root 3. So my final answer here is going to be negative root 3 over radical 3 times radical 3 is radical 9, but that's just equal to 3. So here is my final answer. I'm going to go a little bit lower here and do tangent of 180 so that I can draw my unit circle. So for 180 degrees, let's make our unit circle, but this one's a quadrantal angle. So finding the ordered pair at 180, I know that that ordered pair is negative 1, 0. So for the tangent of 180, we're going to have to say the sine of 180, 0, over the cosine of 180, negative 1, but 0 divided by any other number is equal to 0, so the tangent of 180 is equal to 0. So we can evaluate any tangent of any angle, whether it's an angle given to me in degrees or in radians, by evaluating the sine divided by the cosine of that angle. Now in example number 4, we see that we have another angle that's in our unit circle that's another quadrantal angle. So I'm going to draw 90 degrees, or likewise pi over 2 radians. So at that 90 degrees, I know that my ordered pair is 0, 1. So that tells me that the sine of 90 degrees is equal to 1, and the cosine of 90 degrees is equal to 0. So the tangent of 90 degrees, by our definition, will just be the sine of 90 divided by the cosine of 90. But we just saw from our unit circle that the sine of 90 is 1, cosine of 90 is 0, and when I'm trying to divide a number by 0, that answer is going to be undefined. So we might be wondering, when else am I going to have a tangent that's undefined? Well, do you notice that it's going to be any place where my denominator is 0? And since tangent is sine divided by cosine, it's going to be any place where the cosine is equal to 0. So I see one of those happens at 90 degrees. Do you see that the next time that happens is at 270 degrees? Because then my ordered pair is 0, -1. So I'm getting undefined tangents at 90, at 270, and if I keep counting going around my circle, I can keep adding 180 degrees on and getting other multiples of 90 and 270. So here I have as my multiple choice answer 270 degrees because that also has a tangent that's undefined. For our last two examples, we're going to look at evaluating tangent by first of all evaluating cosine or sine from some given information. So in example number 6, it says determine the value of cosine of theta and subsequently tangent of theta if I know that sine of theta is equal to 5 over 13. You'll notice that for this example, my terminal ray falls in the second quadrant, so I'll have to take into account the positives and negatives in that quadrant. So hopefully you recall the Pythagorean identity that we had been using. That says that when I take the cosine of the angle and square it, and then add on the sine of the angle and square that, my answer is always going to be 1. So I would like to solve for the cosine of theta, but I know that the sine of theta is equal to 5/13. So I'm going to square that 5/13 and equal it to 1. So the cosine of theta squared plus 25 over 169 is equal to 1. So that tells me that the cosine of theta squared will be equal to 1 minus 25 over 169. Let's do that subtraction. So cosine of theta squared would be equal to 144 over 169. I just found a common denominator and subtracted. So from that, I can tell that the cosine of theta, when I square root both sides, is going to be 12 over 13. Now, pay attention to your quadrants. Since cosine is the x-coordinate in our unit circle, the x-coordinate in the second quadrant is negative. So I know that I've evaluated for cosine and got negative 12 over 13. Now, if I want to find the tangent, then I'm going to say the sine divided by the cosine. So 5/13 divided by negative 12/13. Remember how we keep the first fraction, multiply by the reciprocal of the second one. And in this case, I see that the 13s are going to cancel. So my answer for tangent is negative 5/12. You'll notice that the positive or negative answer for tangent comes out correctly if I have included the sine and the cosine positive or negative correctly. Now I'd like you to do the you try it, so pause the video and solve this you try it for sine and tangent. And when you come back, you can compare your answer with mine and make sure that you are understanding how to evaluate tangent. Here we see the use of the Pythagorean identity again. So sine squared theta plus cosine squared theta is equal to 1. I've identified the cosine of theta as negative 0.8, so I substituted that in. And when I solved for sine of theta, I got plus or minus 0.6. Now, since my terminal ray was in the third quadrant, in the third quadrant, the y-coordinate for sine is going to be negative. So I said that the sine of theta is going to be negative 0.6. Now, once I know sine, and I already was given cosine, I can evaluate tangent by saying sine divided by cosine. So negative 0.6 divided by negative 0.8 is giving me an answer of 3/4. Now what I'd like you to think about here is how big tangent can possibly be. Think about how big sine can be and how big cosine can be. Is that also true of tangent, or is there going to be a different rule for tangent? So just something to think about. What is the biggest possible value for tangent? Thanks for working today on our third trig function, tangent. We will go ahead and work with these in class again tomorrow so that we are familiarizing ourselves with our third trig function, tangent, especially within the unit circle. Have a great night, and we'll see you next time. Bye-bye.